All right, cool. Well, this is Aaron with 3D Printer OS. Today we are trying our very first live on-air 3D Printing 101 and also kind of a Q&A with our side. From our team, we have myself, Aaron. Nice to meet you. We also have Charles joining us. He's in New York. Charles, if you want to say hi.
Nice to meet you guys. Nice to see everybody. I'll be mediating for the most part today. Aaron will be the showrunner, but I'll be answering questions and just giving general feedback. So if you need anything, let me know.
And just to explain how this webinar portion works, I guess, it looks like there is a Q&A button. If you see a question mark in your top right, you should be able to click that, submit questions, which then we can get a chance to answer. There's also a chat function, but let's put questions in the question spot just because we can do our best to organize and answer. So before we start the class, I just want to start with saying, thank you guys for joining us today. It's a Friday. You didn't need to be here, and we appreciate you coming in. Secondly, this is our very first webinar version of this, so we're interested to see how this goes. I'll reach out to you guys for feedback after. I'm unfortunately in San Francisco at the moment, so I couldn't be there in person in New York, but we still want to do our classes and make sure people can have access to learning about 3D printing. To give a quick background on this class, this is something we started a year ago, and it started out of we were so fortunate to have access to 3D printing and learn a ton from it. We want to give back. 3D printing is incredible technology. We want to share it with you guys. I want to answer as many questions as I possibly can today, so please ask as many as you can. I'll get to as many as I can. And with that, we'll start. So 3D printing, it means so many things to so many people. One of the first things I like to do is start with kind of a question to the audience, and you guys can even put in the chat part maybe some of your answers, is what would you make if you had a machine that can make almost anything? And if there's any answers, terrific. If not, I'll kind of go into what I've heard in the past. I've heard, a child say ice cubes. I've heard a man say, I'd make another machine. I've heard someone say, I'd make a fire truck or something like that. The answer is with 3D printing, we can make bits and pieces of all these different things today. Maybe we can't do it exactly, but 3D printing every day advances in a way where we're getting closer to being able to make all of these wonderful things. One of the first stories I heard when I was starting to learn about 3D printing was the use of how Cornell University was using 3D printing, and they were scanning different artifacts at archaeological digs and then 3D printing them. And that in itself, that's not really that cool a story. The story is cool because they were sending 3D scans, just dropped my duck. They were sending the 3D scans to other 3D printers, and someone broke open one of these 3D printed, 3D scanned cuneiforms and realized there was messages on the inside of these cuneiforms the entire time. So for 4,000-year-old civilizations, they were hiding messages on the inside of these cuneiforms, and we're not going to break open a 4,000-year-old object. Only with the power of 3D printing and 3D scanning, we were able to learn something that otherwise we would have never discovered unless, accidentally tripped, stumbled, and broke something. So that's just a little bit of a background story. And again, there's new wonderful things that come out every day. So what is 3D printing? 3D printing is also called additive manufacturing, rapid prototyping. I've heard tons of different names, and obviously it's something that's been in the news a ton as of late. There are all sorts of types of 3D printing. There are what's called FFF, which is the kind of type we're talking today, FDM, which is very similar. It's a fused deposition modeling, SLA, SLS, and if there's anything specific you want to talk about, we can go towards it at the end. But for today, we're going to talk about FDM, or FFF 3D printing. And the machine I'm going to use to kind of talk you through different pieces is the Ultimaker 2 Go. Before we get into this piece of the actual printer, I just want to give a bit of a history on 3D printing. This is something that's been around since the 1980s. It's been around for a long time, but we haven't really heard about it. And the reason 3D printing has really exploded in the past few years has a lot to do with patents expiring, better computing power, and open source technology in a lot of ways. Being able to collaborate and being incentivized to collaborate and come out with your own printer, it's made it a lot easier to have, now 300 or 200 3D printer manufacturers out there, which really has democratized access to 3D printing, which is just kind of a cool starting point. 1 second here. Going from that, let's start with talking about the type of printer we're going to talk about today, which is the Ultimaker 2, and as I said, kind of the FDM printer. I know that in person, this is a lot easier to kind of see and demonstrate. If you have any questions, I'll come back to it. I'll make it do my best to really explain how things work, but I'm going to try to visually demonstrate, you know, what is something I do want everyone to see in person. So this, in my opinion, is one of the, you know, a great machine. It's just easy to use. You know, there's tons of great machines out there, but this is just a basic 3D printer. So I'm going to go through each piece. Let's start with the top. So in 3D printing, there's a bunch of terms which kind of come from different fields as well. This top part, where this thing kind of moves on, this is called the gantry. This piece right here, where the thing moves. And so this piece can move on an X and a Y axis. Pretty normal stuff. 2D printer can move on an X and Y axis. Now, why is this 3D printing? Because we have ourselves a Z-axis. This part right here, which let me raise up for you guys, this build plate can be raised on an X and Y axis, or on a Z-axis, thus making it a 3D model. It can be built this way, you know, versus where paper printing is just back and forth. Before I even go further, is there any questions on that? Please use the question button and click broadcast message. It'll make it a lot easier. Any questions? Otherwise, I'll move to the next piece on the printer. All right. I don't see any questions as of yet. We're gonna keep going on the printer. So we have our build tray, this little piece right here. This build tray, it can be heated or not heated. In case of this machine, it is not heated. I'll go into why that makes or does not make a difference when I talk about materials, but you know, I just wanted to let you guys know both options exist. Now, the most important piece on the 3D printer, in my humble opinion, we're going to do our best to make it so you can visibly see this, is what's called the extruder or the hot end. I've heard, you know, a bunch of different names for it. Really, the extruder or hot end is a whole bunch of different parts which come together to really be the part which pushes out or extrudes material. When you think of this type of 3D printing, FDM, I've heard the analogy, it's like a glorified glue gun. I'd like to think it's better than that, but in some ways, that's a great way of thinking about it. You know, we're pushing out a material that's heated to temperatures like 190 degrees Celsius or 230 degrees Celsius and pushing it out onto this build platform where it adheres. I hope that makes sense from afar. To spin the printer around a little bit and just give you kind of an idea of what it's built out of. I've seen some of these made in wood, you know, fiberglass, you know, steel assemblies, you know, fiberboard, all different pieces. The 3D printers come in all shapes and sizes and all different kind of body assemblies. I just want to show you guys the back end here because, again, we're doing a general overview. This piece right here is a feeder motor. When I say feeder motor, what it really is, as simple as it sounds, it's feeding material up to that hot end extruder, which is then, again, pushing the material down. When you get down to the science of the machine, I mean, they are hard to work with, but they're actually really easy when you think about it from like a graphical thing. And I will send out links after this for more in-depth, which can kind of reiterate those different pieces. That way you can look at it and visually go through it again. So that's kind of the high-level overview of this piece. Charles, I know you're kind of moderating me right now. As a panelist, do we miss anything in the general before we go into material?
I think we covered the general aspects of it, and I like the hot glue gun analogy. It's essentially, you know, the plastic out and the general materials used. We have a question here.
It is a great question because I wanted to go into materials next. So before I go into materials, I should probably show some. So right here is a roll of the material, the ink, as you can call it, 3D printing. The word that you'll most commonly hear is filament. If I was searching to buy 3D printing material, it would be called through like filament. I'd search filament. Filaments comes in different shapes and sizes, all sorts of exotic materials. To answer that question, what are some of the new materials used for 3D printing? Let me first talk about the most common, and we'll go kind of into the exotics. So this type of material that I'm showing you right in front of you guys today is called PLA. Now, PLA is a corn-based plastic. It's relatively non-toxic. It's probably one of the safest types of 3D printing materials. There's a ton of work being done to make it even more biodegradable, which is awesome. In my opinion, it's the cheapest. It's probably the easiest to get, especially here stateside and also internationally. The other really common desktop 3D printing material is ABS. ABS, on a personal level, I wouldn't recommend printing it in a closed room, but it is also a terrific material. It's more for use with the printer with the heated bed, and to explain the difference between the two materials and what their use cases are. PLA, much easier to use, I think. If you're just starting 3D printing, it's a great starter material. You can pick up PLA. You don't need to know a ton, and you can get some successful prints on a non-heated print bed. ABS, once you really start to 3D printing quite a bit, you're probably going to want to grow to different materials. ABS, you can get really, really beautiful resolution, really pretty prints, for lack of a better term, and there's a lot more options for post-processing, making your prints much more of a finished product. PLA, let me grab my Professor McDuckley here. As you can see, this is a PLA object. You can actually, you can see kind of the lines of the building. Well, I think this is a really cool object. Maybe it's not production quality, but although it is very usable and very strong, just doesn't have that polished look and feel. Now, to answer that question from before, more in depth, different types of materials, there's tons of stuff being done around flexible materials by companies such as like Ninja Flex and Recrius 3D. And these flexible materials, they're ridiculous. I've seen things like, I've seen Recrius print a bouncy basketball, something that can be printed and then bounced on the floor, which is really, really unique and innovative. Same thing with Ninja Flex. Someone who actually attended one of our in-person classes used Ninja Flex to create a food mold for dementia patients. Because Ninja Flex, one of the great properties was it could be frozen. And he was putting different types of food molds, which he would then freeze and then be able to use for helping dementia patients recognize different types of food molds. We can go more into that later, but I blew my mind away. Talking about different types of materials, the exotics, honestly, a year ago, this conversation would have went completely different. When we first started teaching this class, I feel like there was limited options. Now there's all sorts of cool stuff. There's materials such as like a bamboo blend. I think I've seen a hickory blend. There's different types of metal. I've seen, a silver, brass fill, copper fill, bronze fill. And these different types of materials they're terrific. They're still a little more expensive. PLA is cheaper and ABS is cheaper. But the exotic materials, there's so much work being done to advance that side of 3D printing. So there's tons of different materials. And we'll dive more into that at the end. I want to go back around to this piece because there's really cool stuff happening with like chocolate printing and the questions I was like hearing, can you print a pizza? You can, but I don't have that material offhand. Any more questions on maybe the basic hardware and the basic materials before maybe we move forward? And I'll give you guys a second here to type if you have any. Cool. So before we move forward, I do want to talk about one other thing, and that's the reusing of materials. That's a question I feel like we commonly get asked at like an intro 3D printing class is, can materials be reused? So there's been a lot of work being done on this by multiple companies. I think one is Dimension Polymers. Another one is a really cool one out of Amsterdam called Perpetual Plastic Project. What they're doing is working with another company to take plastic out of the canals in Amsterdam and turn that into this filament. So you're reusing essentially what's already been created and discarded. So that's super cool. And there's a lot of work being done around biodegradable filaments. think it's 3D Print Life is doing a lot of work around like even biodegradable ABS, which didn't really exist before. And there's always really cool innovations happening in that field. So if there's any further questions on like material properties and that sort of stuff, we can dive more into that. Heading next into what kind of goes into printing here. Hang on 1 second here. Do we have a new person here? What goes into actually printing? You know, people ask what type of file is printed. You know, how do I actually then take an idea and turn it into a physical object? So we have a printer. That's just kind of step one. You know, now you need a design, or you need to be able to create one yourself. When it comes to design tools, I don't know, you know, what our audience, we have a question. When would you use a hot cool plate? You know what? I'm going to answer that first, then we'll go into the 3D printing softwares. So the hot cool plate is a terrific question. In particular, the hot plate comes in so handy, especially if you live in New England, where temperature changes in a room are rampant. A hot plate is really great for adhering a print to the build plate as the print is being built. So if you could imagine, as you're stacking layer by layer by layer in the 3D printing process, if you have a cool plate, you know, you have to hope the print adheres to the plate because the machine is moving back and forth and side to side. For a printer without a heated build plate, you know, there's tricks. You could actually see in this printer right now that I have blue tape, you know, just painter's tape, Elmer's or 3M painter's tape. And I'll put painter's tape down and Elmer's glue to help adhere the PLA. But for bigger prints, Charles actually printed a guitar, which we loved showing until it got broken in class. It took over 100 hours and it was built in different pieces. Having a heated build plate kept that adhesion while we were doing 30 and 40-hour prints. It made it a lot easier. And when I mentioned ABS, if you're printing an ABS, you need a heated build plate because you really need that adhesion, and the material properties for that kind of require that. So if you're printing in PLA, you know, if someone goes out in this class and buys a 3D printer today, you know, PLA doesn't necessarily require a heated bed. It's a kind of a luxury, but a really wonderful one. If you're printing in ABS, it is required. You know, that's something you would look for. And if you're printing in expensive materials, you kind of want a heated bed too, just because you're spending more money on the materials. I hope that answered your question. And if there's more, you know, feel free to send it in here and I'll follow up on it. Otherwise, I'm going to go into, let me see if I can check that off. Cool. Otherwise, I'm going to go into, you know, taking the idea now and turning it into a physical object, because I think that's an important piece of the puzzle. So I'm not sure how much familiarity you guys have with CAD files or SolidWorks or tons of different things. And got another question here. If I didn't adhere, why would it make a difference? The build plate doesn't move. Oh, you know what? I want to finish this out. So that is a great question. Because it can knock it off the print bed. Let's take my little ducky example. Take my little duck here, put him in the printer. So if this isn't adhered to the build plate and this is moving around, you can actually see here, it would knock my duck off the print bed. The printers, while they're getting better, they're not smart enough to know that they're now printing in thin air. So you really want your print to stay in the original position. Otherwise, you're going to, it would be what we would call a failed print. You know, so adherence to the bed is actually really, really important. And that's like, I would say as you get a printer, that's something, you know, you're going to learn and practice and trial and error with. But a good rule of thumb is a heated build plate is a little easier. And for a non-heated build plate, you know, I do recommend either like, you know, blue tape and Elmer's glue or build tack, or there's some other, you know, materials, but they help tremendously. Any more questions on that before I kind of dive into the software side? Cool. And I'll come back to it. If I missed your question, Tova, I can always come back to it. Diving more into the software side. So now we talk about taking an idea and turning it into a physical object. This is where our company resides. So it's obviously something I'm very passionate about. Most people, when they start 3D printing, you know, the first type of file they think of is a CAD file or maybe SolidWorks or some different type of file. I don't expect everyone in the audience to know how to make one of those or create one of those. totally reasonable. A great resource we'll send out after is Tinkercad. I think Tinkercad is a great starting tool. Charles, if you don't mind putting that in the chat as a link, that'd be terrific. But Tinkercad is a free resource. When we work with educators, it's one of the ones we always recommend. Super easy, has tutorials. Even occasionally in New York, we'll teach a walkthrough class on it. So it's a wonderful starting point for getting your 3D file. But then beyond that, say you didn't want to design something, you wanted to search, there's really cool resources in 3D printing already. There's such resources as Thingiverse, Umagine, and we can dive more into that. But you don't have to just create a file. There's tons of files that are being put online already today. You can download, you can modify, you can remix, as they say, and use for whatever purpose you have, which is really, really cool. Now, this is where it gets tricky, and where if you guys have questions, we'll stop and try to go through them. At the current moment, if you didn't use like my company software, which we'll dive into, but if you each use an individual 3D printer, almost every printer has kind of their own type of software. And those softwares essentially consist of the same parts. There's something called a slicer, which to explain to you guys, and hopefully a way that makes sense, slicing is the act of taking this 3D file and breaking it into different layers, which the printer can then read to create a three-dimensional model. Slicing is really an essential part of 3D printing, being that it's the act of taking something three-dimensional and converting it into something that can be reproduced in 3D again. It's kind of like the Star Trek replicator. Really, really cool and technically complex type of thing. So essentially, every printer has a slicing software it works with and a printer controller. If you can imagine kind of like 2D printing, all these different printers have different controllers and drivers, and this is something we can dive more into, and if you guys have individual questions, you can always follow up with me with. Where we work, kind of how our company is trying to approach this topic, is we've built software which combines all of the pieces of 3D printing, the controller and the slicer, and also even the visualization piece, taking this file and looking at it and modifying it, so you can do it all from one place, and you can do it really easily. And at the end of this, we'll also send out a link. You guys can all play with it. It's free, and I think it's something. If you have any questions on, you could again reach back out to us. But so now you have your CAD or your file. A CAD file is just kind of the base. The file most associated with 3D printing, I don't know if you're writing this down or if you're researching it, is called an STL. It is a really, really old file type. It's been around since the 80s. I think it's a stereolithography file. And an STL is really the base file every slicer kind of operates with. So this duck, went from CAD to really STL to the final product, which is called a G code. A sliced file in 3D printing, when it's sent to a 3D printer, typically is a G code. And for anyone that's familiar with, maybe CNC milling or different types of manufacturing, G code is actually the same type of file type that runs those robots. So there is similarities between the fields, and it's kind of crazy. Before I dive more into the software and kind of talk through this, is there any just general questions on that? Because I think the software is actually where it gets a bit trickier. Any questions? Or Charles, anything you'd want to add there?
I always think of G codes and explaining it is always somewhat difficult, and I always try to look at it as what the G code is you have your physical file, that your 3D file, and really all it is it's a set of instructions for a tool path for that 3D printer. So you're essentially converting the look of this physical object into nothing more than a set of instructions for the printer. So the concept is fairly simple. It goes back and forth and up and down, and you just tell it when to do that, and that's essentially what a G code is. And I always like to kind of explain it that way, but I think we're good.
Terrific. And if you guys have more questions, again, just send them towards the end or whenever you want, and we'll do our best to get to them. And again, one thing we will do is send out links to these different softwares if anybody wants to play with them. Same with more information on the printers. I do want to make sure you guys have access to resources, because really that is where so much of my own learning, and I know a lot of other folks' learning comes from, is just finding out where those resources are and being able to use them. So we do want to get those to you. So now we've covered kind of the software. We've covered a bit of the hardware from the high level. The question I always kind of get next, it goes back to a question we got earlier, is why would I use 3D printing? Or, what types of applications does 3D printing have, or materials beyond just like, Professor McDuckley. And right now, there's all sorts of crazy materials happening in 3D printing, and the applications are changing every day. I did want to touch upon, it is possible to print in chocolate. Even in the White House Maker Faire, they highlighted pancake bot. It's a silly thought in some ways, but we're 3D printing pancakes. It's pretty cool. And when we think of 3D printing, let me see here. I see another questions. Oh, that is a great question. I'm gonna get to that next. But when we think of 3D printing, I just want to really emphasize to think of it in the realm of personalization and customization. Where traditional manufacturing, you can make 10,000 of the same object, and maybe that made sense. 3D printing, it's the exact same effort to make 100 very personal objects or 1,000 really, really personal and customized and perfect objects. We could dive more into that at the end. I want to answer this question. How many layers or slices are there in a G code? That's a terrific question. Depends on the object. So this duck right here, I'm purely guesstimating right now because I don't remember off the top of my head. Maybe had 659 layers or some random number. Charles, I don't know if you have offhand what you showed me earlier, that little 3D, but that had, if you could see that on Charles's screen, that had probably less than 100. So depending on the size of the object as it goes up, that z-axis is how many layers are going to be in the object. I hope that answers your question. And to say how many slices are in a G code, it's just you slice the file one time per print. You might do it before you find the exact object you want. You might slice it 50 times. That's the benefit of 3D printing. There's no difference for me to print. Say if I didn't like this duck and I wanted to change him, I can print him 50 different ways. And actually, I do want to backtrack a second, going into the software and why 3D printing is really useful in that kind of realm too, is not only can you customize the object, you can customize what goes inside the object, how strong it is, what its material properties are. That's really, really important. So for this duck right here, there's a term called infill. Infill is the percentage of plastic which is occurring inside of the object. I can determine that. I can change that per object. Same thing with something called shell thickness. I can determine how big the exterior walls are for that object. So I can build maybe a ducky that I want to float, that I want to leave air inside, so he has only 20% infill. And I can also maybe build one out of like a different material at 100% infill, but just because I have like a different use case for it. So again, this goes to that higher arching topic. 3D printing is something that should be thought about really in terms of personalization. It has a lot of power there and customization, even object to object. Any questions there? Otherwise, I did just want to touch on some other materials you can 3D print in, some really cool use cases just to think on. One of the cooler things I've seen in 3D printing is like printing in ceramics, in metals, in different types of polymers, all sorts of wild stuff. A good example for if anyone's kind of looking online is I've seen an espresso cup, something that can only be created via 3D printing because of the airwaves inside or that are outside the cup. So it can be held without dissipating the heat inside the cup, and it can only be made via 3D printing because traditional manufacturing, injection molding can't handle that kind of shape. And the company that makes that cup is a New York company. That's how I remember them, by the name of Behold. Really, really cool espresso cup if anyone's checking out different 3D printing things. Before we move kind of into the next topic, the next topic is I want to touch on other 3D printing types, kind of go through some medical stuff and 3D printing today, how it's being used. Is there any questions on general hardware and software? I want to make sure we get to those, and we could come back, but if there's anything now, please type it. It's a lot easier on kind of getting to it. I'm gonna go with no. We'll keep going. So I did want to dive into 3D printing today and different printing types. So I'm talking today about, as I mentioned, this FDM, FFF type 3D printing. Now, another really common type that people I've heard mentioned a bunch of times is because they saw Carbon 3D in the news, and it's like that one that looks like Terminator, where the object's just rising out of the liquid and they're doing the Eiffel Tower in like 7 minutes. That's a type of printing called clip. I think it's a proprietary method. It's a really, really, really innovative and cool way of printing. I haven't even seen the printer in person, but Like that's a type of 3D printing. And then there's all these other types like laser sintering, you know, and then there's SLA. SLA is like the type of printing that uses resin. You can create really high resolution pieces, and in that type of printing, it's really growing as a market because you can make jewelry. You can build jewelry parts with exact precision 100 times or 200 times over before then sending it to get molded. So these different types of 3D printing, I've learned about them by kind of starting here and then growing out. And for anyone who's maybe doesn't have a 3D printer yet, they're looking to get started. The world of 3D printing is growing so quick and in so many different ways. I highly recommend kind of getting your hands on one or touching one. And we could recommend some resources for that as well. Especially in New York, there's some great resources and wherever you're watching this from. Any questions on that? Otherwise, I want to talk about medical 3D printing and kind of how that's being used today. So to dive into kind of medical 3D printing, because I think that's another really common question because people hear about it. 3D printing is super, super disruptive in that you could take a 3D scan and then recreate an object. So 3D printing today, we do see a lot of people, possibly scanning someone's jawbone and then being able to recreate that jawbone, prototype it multiple times in maybe plastic. And then in Europe, they've recently then 3D printed it in titanium with room for cellular membranes to kind of connect back into the cellular lattice and grow. That's crazy. So the medical applications for 3D printing have been exceptional. And the most 3D printed object in the world, just to give everyone here kind of a heads up, is actually Invisalign, the braces. And I'm not sure if everyone's aware of that, but Invisalign is a 3D printed object, and it makes perfect sense because you could take a scan of the mouth, and as his teeth change, you can 3D print a new mold, which can then be put in the mouth, which is, to me, is wild. So moving kind of into bringing us to like today's world of 3D printing, I want to kind of talk through 3D printing in today's world. How we use it, how I see other people use it, and if you guys have any things you want to contribute or any questions, how you guys see it being used, and we can talk through that. So a project that is near and dear to my heart is the Enable project. I'm not sure if everyone's familiar with that. Enable is I think they describe themselves as a passionate group of volunteers coming together to make a difference with 3D printing or something along those lines. And what they've done is, between engineers and people with 3D printers and the like, they've created a hand file which can be 3D printed on just these type of printers here that I'm showing today. These desktop 3D printers that can be printed and is for about $2 to $3 in power and $25 in assembly costs, is comparable to a $40,000 prosthetic. So that's incredibly, incredibly, incredibly disruptive to not just the healthcare industry, but kind of the way we help people around the world. So the Enable project, and that's a link I'll send out after, has really, really connected people without access to maybe 3D printing or without access to traditional medical care, and been able to give them access to hand kits. And if you have a 3D printer and you're in this chat, I encourage you to check them out and print a hand. They're actually we're running a challenge with them right now. This cool the scuba duck shirt I'm wearing right now. If you print a hand out through our software and our system and let us know that you did it, well, I'll send you a shirt. It'd be our pleasure. Enable is doing great things, and I really want to get the word out about that kind of use case of 3D printing. Also kind of talking about today, making usable things. This is just a personal project I like sharing, is making bicycle pedals. I'm big into biking. I think it's a wonderful thing. I like being able to 3D print useful things. One of the biggest knocks on desktop 3D printing sometimes is, hey, you're just printing tchotchkes and trinkets and all these random things. You can make usable things today. And one of the things that we've made that's usable, and I'll send out a link after, a funny video of me riding around, is bike pedals. You can use this type of plastics, even PLA, print it out, with the very specific settings. I typically recommend like 40% infill and all. I can send the specs. And create something that's usable and can replace a broken bike pedal. I had a broken plastic piece on my pedal. I was able to replace it with my new 3D printed pedal, and it's still going strong. It's something, and if it breaks, guess what? I'll print another. And even crazier, you talk about disruption. Maybe some of you are familiar with Amazon Prime. You know, that's typically 2-day shipping. I could 3D print a set of bike pedals in 14 hours. So to me, that's disruptive. Overnight, I can have an object that I can then use, which is super, super cool. One last use case, just on a personal level, is I'm not sure how many people are familiar with the faucet in your backyard. I think it's called a spigot. Mine broke, you know, and that was frustrating. I was like, you know, I should go to the hardware store and buy another one of these pieces. But I was able to go to thingiverse.com, find a file with the exact key, the exact spigot, you know, within moments, print that out. You know, about 30 to 50 minutes later, I had my object printed and replaced and fixed. 3D printing is definitely one of those things where, as you have access to it, you start to think in 3D. You start to think, what in my daily life can I use this machine for? And I find in my own personal life, every day it increases. You know, it's not just cell phone cases and really cool big ducks. It's useful things. If something breaks in my car, you know, being able to 3D scan different pieces and replace them. There's some really great use cases. And I could talk through with anybody after on these different things. I just saw a question come through from Tova. Where can we learn how to use the software? So there's different resources. For my company software, like 3DPrinterOS and what we're doing, we have walkthroughs and tutorials online. Also, you know, we try to host these type of things where we can walk you through it. We'll send resources to that after. For any of the other types of software, like Tinkercad, which I think is really essential to kind of learn, Tinkercad has terrific walkthroughs on their site. I think Charles sent the link, but it's Tinkercad, TINKERCAD.com. And they have a set of tutorials you can walk through to really teach yourself the basics of design. Some other great design programs worth checking out are SketchUp, which is a really, really cool one. FreeCAD, and as you get more advanced, or maybe you're already super advanced, you know, there's like the whole Autodesk suite of products, which kind of includes Tinkercad. I mean, they own that as well. So there is a ton of options, and that's design. For printing software, you know, I'm biased. It's no matter what machine you buy, you can use our software. So I think it is a little easier to learn, and the learning curve is a lot shorter. So, you know, if you have any questions, let us know. If it's for any machine-specific ones, I know Ultimaker does a good job of like putting instructions with theirs. Their software is called Cura. That's their base level one. You know, MakerBot has instructions with theirs as well, Makerware. But again, you know, if you have any questions, you could always follow up with us. We do want to be a resource for any questions you have moving forward too. Any questions overall? I feel like in the 37 minutes we've been live, we've covered a ton of ground. I probably have talked a mile a minute because 3D printing, like once you've kind of seen it and get hooked, I admit I'm addicted to 3D printing. It's kind of ran my life, and I love it. The first time I saw it, I was mesmerized, really haven't looked back since. And I feel when you can see objects that you dreamed then become physical objects, it's enthralling. It's a wonderful, wonderful feeling. So is there any questions before we kind of dive into, you know, following up with some different things and kind of closing out here? If you have any, just put them in the chat. Let me see here. Cool. Now, one thing I did also want to talk about, because I do hope we encourage you guys to get out there and try 3D printing, is there will be failures. I want to be very, very upfront with this. This is still an industry where there's work to be done by not just software, not just hardware, not just materials. It's still growing. You know, a year ago today, like I said, there was tons of different materials available. There wasn't nearly as many materials available as there is today. And so the more people who get involved in 3D printing, the more people who learn, the more people who contribute, the faster we grow as an industry, the easier it gets. But failed prints will happen. I'm going to warn you in advance. And I would never get discouraged because in 3D printing, you know, you can just try again. You can try another file. Thankfully, the filament is getting cheaper. You know, you can really, really keep trying. It's a wonderful thing. And there's the 3D printing community is really incredible. If you have any questions, you know, typing it into Google, there's tons of resources. There's forums, there's support groups. You know, like we have a forum, we see people ask random questions unrelated to anything we do. That happens. In all the other 3D printing forums, people want to help. This is something a lot of us who are in the industry want to share with other people. You know, I've probably told every person in the world I know about 3D printing and will continue to do so. So, you know, there's lots of resources for continued learning. let me see here. So one of the last things I did want to talk about is where 3D printing is going to, just kind of the end here. So as I said, 3D printing is still growing, early industry, different pieces. As folks go out and learn about it today, one thing I'm going to say is you noticeably don't really see any big name players, whereas there's no HP really involved too much yet. Canon, they're really, even Microsoft, they're getting more involved. But as that changes, I think 3D printing is drastically going to grow too. One of the things I would highly recommend watching maybe after this is HP, they did a demo of their printer. They printed a hook that can suspend a 10,000-pound car in just 30 minutes. In GE, they're doing incredible things around printing jet engines right now. They're prototyping. They're consolidating 9 different parts which were traditionally manufactured into one part that can be 3D printed. So there's just tons of opportunity in this field, and if it's something you're interested in, I really encourage you to kind of take that step further and keep progressing with it. Is there any other questions today? Like I said, this is our first webinar. We wanted to test this out, try to open this up to a wider audience. If there's any other questions we could possibly answer, awesome. If not, we're going to send out a list of resources after. And one of the things, I always will say is, you guys can all have free access, free trial of even our premium features, and we have our software. We have a whole free version, and will always be free and it's fun to play with. So please check that out too. And if you have any questions on 3D printing, let us know. Otherwise, I want to thank everyone for joining us today. This was an experiment on both ends, and we're going to be hosting more of these in the future. And if we at our next in-person in New York as well, or here in San Francisco, we do encourage you to join us. Otherwise, thank you, everybody. This was a wonderful experience, I hope, for both sides. Charles, if you have anything to add, terrific.
No, I think you covered everything. Like I said, the only thing I would say is, we'd love some feedback. This is our first web session. It's kind of spur of the moment for us, but we'd love some feedback.
There's a last question. I'm sorry. I do want to get into that, Judith. So Judith asked a question to talk about 3D scanning. So I have a 3D scanner floating around where I am right now. I think it's awesome. I know that's not really talking about it. It's the high level. So there's tons of different options in 3D scanning today. The ones that I would, to talk through how kind of it works, is there's like photo-based ones, which can be used on your iPhone. And a good application of that is, I think it's called 123D Catch. Maybe, Charles, you could put that link in the chat. That's a free application by Autodesk, which can, I'll get to that one next. That can be used to take a bunch of photos of something, maybe 40 photos of this, and then convert it into a 3D file, which you can then pull from. Moving kind of up the chain, there's a $400 scanner by 3D Systems called the iSense. I've had access to one of those before. It's really, really cool. It typically works with either an iPad or with your computer, and actually it's pretty good at representing facial features. So if that's something that's affordable, especially if you've invested $1,000 in a 3D printer, there is 3D scanners that are low cost, which can do a pretty great job of scanning, daily objects. And scanning, just to finish that out on like use cases, is you can scan things and pull them out. So like a project I'm working on is scanning my glasses, the lenses, and being able to print myself, customized glasses. If you have further questions on that, I can dive back into it. But on the high-end level, the 3D scanning, I still have more to learn. I've not had access to like the $50,000 reverse engineering scanners. They do exist. I don't really know the technology or software behind it. But I do know that some of that technology is trickling down, and scanning on the desktop and the consumer side is getting affordable, and it's becoming very powerful. Next question I saw is 3D scanning. Can you print something that's more than one color? Yes, absolutely. That's a terrific question. I'm sorry I didn't answer that to start with. So right now, this printer, let me pull it back on the screen here, has, you see the one extruder, the one hot end. To print with more than one color here, I would need to change the material as I was printing. But what we're seeing now is printers with multiple extruders or multiple hot ends. And I'm talking only on the desktop for more than one color. For the higher end printers, Absolutely. Higher end printers are using maybe pellets or plastic, or especially for like laser, all those different things. You know, your materials are blends, not just one color, but more than one material. On the high end side, I can print, you know, an aluminum alloy blend or like a tungsten blend, which is like a hodgepodge of different materials. So you can definitely print more than one color even on the desktop printers. You either need more than one extruder or you change materials as you go. There's also different extruders by a company called E3D, which I think can combine filaments and give you, like, say if you combined blue and yellow, you could get green. I've not tested it personally, but I do know they exist. So I hope that answers that. Where can you find a 3D scanner? There's a ton of good resources. I think actually, I'm not sure if they're still open, but the website I used to use was called Aniwaa, ANIWAA. It was like a resource for researching different scanners and pieces, but also like there's tons of 3D printing news sites, 3dprint.com, 3dprintingindustry.com, 3ders.org, and they have different resources for hardware, software, scanners, different pieces, so you can research there. And also, I'm not sure where anyone's located, but if you have like a retail store nearby, it's always really cool to go in and try them. And for 123D Catch, download it. It's on your phone. Just download it and try it. If you like it, great. And also Xbox, I think, not Xbox makes one, but the Xbox Connect can be used as a scanner, and that's something like there's an Instructable for if you want to look further into it. That was fantastic. I like that. It's a good comment. I appreciate that. Thank you. How did we get into 3D printing? What's our educational background? My background to start with is basically like law and starting entrepreneurial type things and kind of training, education. Those are like real things I'm passionate about. I got into 3D printing the same way you are right now, by going to a class, by asking questions, by learning. The next steps for me after this was I started reading a ton about it. I read an incredible book, which is like my Bible of 3D printing. Yeah, I'm totally willing to shout this book out. It's called Fabricated by Hod Lipson and Melba Kerman. Blew my doors off. Book was incredible. Just really great overview on 3D printing. There's also some other books that I think have came out since. I think it's called Makers by Chris Anderson. That's another good one. Reading through those really helped. Charles, if you want to explain kind of your background maybe and how you got into it.
So, yes, absolutely. So I actually, right before I got into, I was working in the medical device field, but I've always been super interested in it, and began working actually with Aaron, helping out with 3DPrinterOS slightly after he got into it. And I think the real catalyst for myself getting like really deep into 3D printing was once I learned about it, I noticed the extreme lack of knowledge around it in general. Everyone was interested but never knew anything. So we started hosting these classes in New York City. And, you know, once I started seeing, you know, like how much that was helping people and really the traction with it, it just blew up. So really, I mean, like Aaron went to a class and, you know, I started helping teach classes. So that's, I mean, it all comes back to helping other people learn about it, teaching each other. And that's really what 3D printing needs right now is a community of people that are like, you know, offering resources if you have them to others. And that was really the catalyst for how I got into 3D printing.
So is there any other questions? I mean, again, I can't say more than enough. I just appreciate whoever's attended. It's a Friday afternoon. Thank you guys. And I mean, if there's any further questions after that, if you're part of our meetup group, you know, you could send them through there. That's at learn3d.nyc, or you can follow up with us on 3dprinteros.com. Again, I'm going to send out a link to 3DPrinterOS after this to everyone who attended. Again, for more information on our software, our company, and some of our stuff we're doing around education, it's 3dprinteros.com. I'll send the link after. So to just kind of sign off, I'm Aaron. That was Charles. Thank you guys for joining us for kind of a Q&A with 3DPrinterOS and 3D Printing 101. You guys are all awesome. Thank you.
Thanks, everyone.